Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. We are from Group 7. So for today, we would like to talk about the selection and arrangement without repetition. So before that, I would like to introduce my co-members. Firstly, Muhammad Norman bin Samsudin, which is Hassan. And the second one, Alisa binti Nur Azmi. Then Fikri bin Muhammad Suhaimi. And last one, Muhammad Syahmi bin Nasruddin. So for the introduction, we would like to talk about the how can we apply what the solution we want to solve, and we would like to talk about the formula, how we derive the computation and combination formula, and then we go to the sample question. Then we jump to conclusion and what the application of this for the combination and permutation. For introduction, many counting problems can be solved by finding the number of ways to select a particular number of elements from a set of a particular size, where the arrangement of the elements selected important or not. For example, in how many ways can we select 3 students from a group of 5 students to stand in a line of for a picture? How many different ways can the letter of the word optical be arranged? In this section, we will discuss on how to derive the formula and to apply it to solve any problem related. Then the next presenter will continue.
Hello and Assalamualaikum. My name is Alisa binti Nur Azmi with the metric number 205751. Today I will discuss about permutation without repetition. The permutation without repetition is an arrangement or listing of objects in which the order is important. In other words, it's the difference of an element that can be done so that two groups differ from each other only in the order the elements are placed. Let's consider that set A is ABC. Then the permutation of these three elements are ABC, ACBB, ACBCA, CAB, and CBA. If one of the permutation is used, it cannot be used again. For instance, BAC has been used, you cannot use it again, and the next permutation is BCA, then CAB and CBA. The number of permutations of an element is given by the following formula. Pn equals to n factorial, which n times n minus 1 times n minus 2 to the times 2 times 1. This means that permutation without repetitions, our choices get reduced each time. In this example, we know that one of the possible permutation is ACB, and the n equals to 3, and therefore P3 equals to 3 factorial is 3 times 2 times 1 equal to 6 different permutations could be formed. In other words, there are 6 different ways that 3 letters could be arranged out of 3 letters. Next, number of permutation of m different things taken r at times is npr. Let's assume that there are boxes and each of them can hold one thing. There will be as many permutation as there are ways of filling in r vacant boxes by an object. Number of ways first box can be filled is n, and the second box can fill is n minus 1. Third box is n minus 2. The fourth box is n minus 3, and the r box can be filled is n minus r minus 1. Therefore, number of ways of filling in r boxes in successions can be given by n times n minus 1 equals n times n minus 1 times n minus 2 times n minus 3 to the times n minus r minus 1. This can be written as npr equals to n minus 1 times n minus 2 times n minus 3 to the n minus r plus 1. The number of permutations of n different objects taken r at time where r more than 0 and less than equal n and the object do not repeat is NPR equals to n times n minus 1 times n minus 2 times n minus 3 to the n minus r plus 1. Multiplying and divided by n minus r times n minus r minus 1 to the 3 times 2 times 1, you can get this equation which equals to n factorial over n minus r factorial. Hence, the formula of permutation is P and R equals to n factorial over n minus r factorial, where r more than 0 and less and equal to n. Another example is in how many ways can 6 people can be seated in a row of 6 chairs? There are 6 people that need to be seated in a row of 6 chairs. The first person can sit on any 6 of the chairs, then the second person cannot sit in any 6 chairs because one chair is already taken by the first person. So there are only 5 chairs left to be seated by the second person, and so on. We can use the permutation formula is P66, which 6 things taken 6 at a time. Equals to n times 5 times 4 times 3 times 2 times 1 equals to 720 ways, which 6 people can be seated in 720 ways. Thank you.
Assalamualaikum. My name is Fikri and my matrix number is 205907. So now I will explain about combination without repetition. So what is combination? Combination is a selection of R elements from a set of N elements where the order of the arrangements of each element in a combination does not matter. So for example, let us consider that we are required to think of multiple ways to select 3 elements combination from a set of 5 elements, where the set is 1, 2, 3, 4, 5. And for our first combination, we decided that the combination will be 2, 5, 1. And then next for our second combination, we cannot choose 1, 2, 5 or 5, 1, 2 because in the concept of combination, these two have the exact same elements as the first combination. Therefore, they are considered as one distinct combination, which consists of element 1, 2, and 5, regardless of the arrangement of elements. In other words, the uniqueness of a combination is not in how the elements are arranged. However, it is about which individual elements that we select to pair them together to form a combination. Uh, but what does without repetition means? It simply means that for every combination that can be formed, there must not be any repetition of any elements inside the combinations. So if we go back to the example again, we see for one of the possible 3 combinations that can be formed is the 251. So notice how when we decided that the first element is 2, we did not reuse the same element 2 again for the second and the third combination. So this is basically what without repetition means. And basically what combination without repetition means is that where not only arrangement of elements does not matter, but also each element in the combination must be distinct from each other. So next slide. So how do we calculate all possible combinations without repetition from a set of a lot of elements such as 23 or 50 elements? It can be very tiring to write down every single combination just to find the number of ways without using a formula. So how do we find the formula? First, we need to understand that for every group of elements that contains 3 elements, there are 6 different ways for arrangements or permutations that can be formed. So for example, in the diagram, you see for a combination of 1 to 5, there are 6 different ways to arrange 1 to 5, 1, 5, 2, 2, 1, 5, 2, 5, 1, 5, 1, 2, and 5 to 1. Or more simpler, we can use the permutations factorial formula, which is 3r factorial. In this case, it's 3 factorial because we use 3 elements. So 3 times 2 times 1, we get 6 different arrangements. Then next slide. So now, after I've explained the previous R factorial, I will now explain how we get this combination without repetition formula. So the first step, uh, let us consider that the formula above, which is the permutations without repetition formula that we discussed just now, equals to result. And then we use the equation where result is equals to A times B, where A represents the number of ways that R distinct elements can be selected to form a unique combination, which if we remember back, this is the same definition as the combination without repetition. So this is what we want to find, the A. And B represent number of ways arrangements of the selected group of elements, or the R factorial, which we discussed in the previous slide also. So we want to find A, which is the combination without repetition. So how do we do that? Is the result, which is the formula above, we divide it with B, the R factorial. So next slide. So this is what I'm talking about, where we take the permutations formula, the result, we divide it with B, which is the R factorial, and then you see that n factorial over n minus R factorial divide R factorial equals to n factorial divided by n minus R factorial times 1 over R factorial. And then step 3, we complete the derivation of formula, which is n factorial divided by R factorial times n minus R factorial, where n is equal to the total number of elements in set and R is the number of elements that we need to select to form a combination. Then next slide. So this is a simple example where we use combination without repetition. A simple situation. It says that in how many ways can we select 3 students to form a group of 5 students to stand in line for a picture? So we can use the combination formula C and R. N is the 5 because that's the total number of students, and 3 is the one that we want to select. And then we can just straight away substitute the 5 and 3 into the formula. So 5 factorial over 3 factorial times 5 minus 3 factorial, we get 5 factorial over 3 factorial times 2 factorial, and we get 10 combinations. So therefore, there are a group of 3 different students can be selected in 10 ways to stand in a line for a picture. So that's all for me for combination without repetition. Move to next person.
Okay, Assalamualaikum and very good morning. So I will continue with a few sample questions that frequently asked for permutation without repetition. So the question is, a code have 4 digits in a specific order. The digits are between 0 until 9. How many different permutations are there if one digit may only be used once? So this is what we call without repetition, where we can only use it once. So a 4 digit could be anything between 0000 to 9999. Hence, there are 10,000 combinations if every digit could be used more than once. But since we are told in the question that one digit only may be used once, it limits our number of combination. In order to determine the correct number of permutation, we simply plug in our values into our formula that have been explained by Alisa before this, which is n factorial over n minus r factorial. So based on this question, we get that in our number from 0 until 9, we have 10 numbers of element. So we can put n as 10. So, and we want to choose 4 digits, so we can put r as 4. So we insert the numbers in the equation, and we will get 10 factorial over 10 minus 4 factorial equals to 5040. And in our example, the order of the digits were important. So this question, we need to use permutation, since the order of the digits are important. And if not, we need to use the combination combination formula. So I will continue with the example for combination without repetition. The question is, out of 7 consonant and 4 vowels, how many words of 3 consonant and 2 vowels can be formed? So the number of ways selecting 3 consonant out of 7 and 2 vowels out of 4 is 7, 3 times 4, 2. So based on the formula, we get to choose that 7 numbers of component, and we need to choose 3 out of 7. So we need to do it one by one. So we insert the numbers in the formula. 7 factorial over 3 factorial times with 7 minus 3 factorial, and because of we need to combine it, so we need to times with the vowels one. So we need to choose between we need to choose 2 between 2 from 4 vowels that have been given. So we insert the number in the formula. 4 factorials over 2 factorial times 4 minus 2 factorial, and we times both of them, we get 210 ways. But since each group contains 5 letters, which can be arranged amongst themselves in 5 factorial ways, in 5 factorials, which is 120 ways, the required number of words is 210 times 120. So we got that we have 25,200 ways of arranging this number. So I will pass to the next presenter.
Okay, for the application, so the first application is for the areas of combinatorics. Permutation usually used in communication networks and distributed systems. Routing different permutation on a network for performance evaluation is a common problem in this field. Then the next one is computer architecture. Design of computer chips involve consideration of possible permutation of input to output pins. Field programmable interconnection chip provide user programmable interconnection for a desired permutation. Then the lastly, simulation. Permutations and combination can be employed for simulations in many areas. Permutation representing various genotype and phenotype association employed in genetic simulation. Okay, that's all I think from us. Thank you for hearing. That's all from us. Thank you.